Today we're going to be reviewing lines and quadratics. So first we're going to start with linear relations. So we have the equation y equals mx plus b. Our m stands for our slope and our b is our y-intercept. Okay, another way we can have slope is saying rise over run. And our b being our y-intercept. So when we look at an axis, we have our x and our y. So it is going to be, our y-intercept is going to hit this line here. The other important thing to remember when we graph points, our coordinates, we always have x first and then y. So that is our point on our graph. So these first examples show graphs of lines. We want to determine what our m is, so what our slope is, and what our y-intercept is. So the first one, we can see that it crosses at this point right here, which is a positive 5. So our b is going to be 5. Now, in order to determine our slope, we want to find another nice point that's on the graph. Try to find where a point meets both grid lines. So that could be this one right here. Okay, with our slope equal to rise over run, we want to see with our rise how many it goes up or down, and with our run how many it goes over. So to go from this point to this point here, it's going to move down 1 and over 1, 2, 3, 4. So our slope is going to be negative 1 over 4. We have a negative 1 because it's going down instead of up. Second example, first we want to look for our y-intercept. So it's crossing right here. And it's between the 2 and the 4, so that's at 3. Our b is equal to 3. Now again, we want to look for another nice point on the line where it's crossing both of our grid lines. So that would be right here, would be a nice one. Now going from this point to this point here, we are going to notice that we go down 1, 2, and over 1. So going down 2 means we have a negative 2 over 1. We can simplify the negative 2 over 1 to just equal negative 2. If we wanted to write these as the equation of a line, we have our y equals mx plus b. So we would just sub in our m and our b into the equation here. So the first one, we would have an equation y equals negative 1/4 x plus 5. Our second one, we would have an equation y equals, our m is negative 2, so negative 2x. Our b is 3, so plus 3. Okay, so we need to move in the opposite direction this time. So now we're given the equation instead, and we need to graph it. So we want to look at our equation, determine our y-intercept, determine our slope, and then we can graph it. So looking at the first example, we have y equals 2 over 5x minus 3. our b value, our y-intercept, is this value on the end here. So our b is -3. And our slope m is in front of the x. It's 2/5. So what we're going to do is start by graphing the y-intercept at -3. So that's right here. Then we are going to use our slope to move to our next point. Again, our slope is rise over run. So here we have a rise of 2. It's positive, so it means we're going to move up. And then our run is 5, so we're going to move to the right 5. So we go up 1, 2, and we go over 1, 2, 3, 4, 5. So that gives us a point here. Once we have 2 points, then we can make our line. Please use a ruler while you do this. It's a little hard for me on the iPad here. Looking at the next example, we have y equals -4x plus 8. So our b is the number by itself, which is 8. And our m is the number beside the x, which is our -4. So in order to make that into a fraction to have our rise over run, we can just make this over 1. And we still have the same slope. So start by graphing the y-intercept of 8. That is going to be the point right here. From there, we have a rise of -4, which means we're going to move down 4, and a run of 1, so move to the right 1. So we go down 1, 2, 3, 4, and we go over 1, gives us our next point right here. Okay, you can continue to add more points if you want. You can go down another 4 and to the right 1, put another point. As long as you have the 2 dots, you can create your graph. You just connect those and you'll have your line. Okay, graphing using x and y intercepts. So we notice here we have our equation of a line, but it's arranged a little bit different. We don't have our y equals mx plus b anymore. So with this, instead of rearranging our equation, we can also graph using the x and y intercepts. So if we're talking about our x-intercept, that's going to be along the x-axis, and that means our y value is going to be 0. So for an x-intercept, y equals 0. And opposite of that, for our y-intercept, it's going to be along this line, which means our x will be 0. So for our y-intercept, x is 0. So in order to find what those x and y intercepts are, we need to plug the y equals 0 into the equation here, and then we'll need to be plugging in the x equal to 0 into that same equation. So first, if we put y equal to 0, we're going to have 2x plus 3 times 0 equals 12. So 3 times 0 is 0, so we're just left with, we're just left with 2, we're left with 2x equals 12. And getting x by itself, we need to get rid of the multiplying by 2, bring it to the other side, we divide. So x equals 12 divided by 2, which means our x is 6. So that gives us an x-intercept at 6. We can put that point on the graph right there. Now we need to do the same thing for our y-intercept, meaning we are putting into the equation that x is 0. So 2 times 0 plus 3y equals 12. 2 times 0 is 0, so we have 3y equals 12. And getting y by itself, we need to do y equals 12 divided by 3, and that gives us a y-intercept of 4. We can plot that point here at a y of 4. Now we have 2 points, and we can make our line. Okay, and next example, we have negative 3x plus 6y equals 24. Again, graphing using the x and y intercepts. So first, let's figure out our x-intercept, and that means we want to replace y with 0 in our equation. So negative 3x plus 6 times 0 equals 24. 6 times 0 is 0, so we're just left with negative 3x equals 24. And lastly, to get x by itself, we're going to have to move that negative 3 to the other side, and we'll have 24 divided by negative 3, which gives us an x of negative 8. Let me put the other step in here. 24 divided by negative 3, x equals negative 8. Okay, we can graph that point. X at negative 8 is right here. Now we need to find our y-intercept, which means we need our x to be 0. So in the equation, negative 3 times 0 plus 6y equals 24. Negative 3 times 0 is 0. We have 6y equals 24. To get y by itself, we need to get rid of the 6 in front, which means we bring it over and divide. So y equals 24 divided by 6. And we get our answer of y equals 4. Okay, we want to graph the point of y equals 4. That's the y-intercept right here. Now we have 2 points, and we can make the line for our graph. There we go. Okay, so that's all our review for linear relations. And now we're going to look a little bit at quadratics. Okay, so this is when it forms a parabola on a graph. You see that it kind of makes that U, this is an upside down U, but it will have that U shape. So it's either going to open down like this one, or it can open up as well. So looking at the graph here, we want to answer the questions. We notice with the graph, it's telling us the flight of a ball. Along the x is giving us our horizontal distance. Along the y is giving our height. So the first question is asking, at what height was the ball initially thrown? So being initially thrown is starting at the 0 point here. So where is the initial height? We see is at this point here, which is 2 feet. Number 2 is asking, what was the maximum height of the ball? So we want to follow the parabola and look for the spot where it is the highest. And that is going to be at this point right here. If we follow that point across, our maximum height is 12 feet. Number 3 is asking, at what distance was the maximum height reached? So still looking at that same point, we have a height of 12 feet, but it's asking what the distance is. So the horizontal distance, looking at the x-axis, what that value is. So taking the same point, but going down instead of over, we notice that matches up at 10 feet. Okay, and last question here. What distance does the ball hit the ground? So when it hits the ground, it's at a height of 0. So we're looking at the parabola at the y-axis where it hits 0. And that's right here. So the horizontal distance for when the ball hits the ground is 21 feet. Okay. So that's the graph of a parabola or a quadratic. And now we want to look at an equation and see what it tells us. So looking at the vertex form of a quadratic, we have y equals a times x minus h squared plus k. The a in the equation here is going to tell us whether our parabola is opening up or opening down. So if a is positive, that means the parabola opens up. And if the a is negative, it means it opens down. Okay, by opening up, it means like so, kind of have your happy face, and opening down will be this way, and we have a sad face. Now, in the equation, we have h and we have k. What we need to notice here is that there is a negative before the h. So pay close attention with this here. We have our h and our k, and this gives us the vertex of the parabola. So looking at a parabola, the vertex is the maximum or minimum point. So if it's opening up, the vertex is right here, and it gives us our minimum. And if it were opening down, our vertex would be here, and that gives us a maximum. So looking at the first equation here, we have y equals 3 bracket x minus 2 squared plus 5. So we have a positive 3 out front. Positive means it opens up. And we are now looking for our vertex. So like in the original, we have a negative here, a negative here. So that makes our vertex 2 with our h, and our k, our number on the end, is 5. So our vertex is 2, 5. Looking at the second example, y equals 4 times x plus 3 squared minus 1. We notice we now have a plus here instead of a minus, so that is giving us a negative x value for our vertex. Looking at our A, we have a positive A, so this one also opens up. And our vertex, because of the positive here, we have a negative x, so a negative 3. And our k on the end is a negative 1, so that stays the same, negative 1 here. Okay, so a couple more examples with this. We have a few equations to look at. The first one, y equals 4x minus 2 squared plus 8. So we have a positive a value, which means it will open up. If it opens up, meaning looks like so, then we are going to have a minimum. Now our vertex, we have a minus 2 here, which means our h value is 2, and our k is the number on the end, which is 8. So making a sketch of this, we know it opens up, so our parabola is going to look like so, and we know the vertex is at the point 2, 8. Looking at the next one, y equals negative 2, x minus 1 squared minus 9. Our a value is negative, so it's going to open down. When it opens down, we have a maximum. And our vertex, looking at our h, we have a minus 1 here. That makes our h1. Our k is negative 9 on the end. Okay, making a sketch, we know our vertex will be at the point 1, negative 9, and it's opening down. It will look like so. The final one here, y equals x plus 3 squared. Out in front here, it doesn't show a number. That invisible number there is a positive 1. Since a is positive, it is going to open up, which means we have a minimum value. Now, looking for a vertex, we have a plus 3 here, which means our h is going to be a negative 3. And our k. There is no k here, which the value would be 0. So negative 3, 0. So this will actually fall on the x-axis. We have it opening up, and our vertex at negative 3, 0. Okay. Please let me know if you have any questions, and go ahead and work on the worksheets for today.